everybody, how are we doing? We got some lunch right here. It's lunch. What can I say? Hopefully everyone's doing well. It's 2 p.m. in Knoxville, 1 p.m. over here. Getting everything loaded up. We should be broadcasting live on YouTube. Live in 4 hours, it says. We're not broadcasting on that one. Live, we got 4 people watching. There we go. Just listening to the stream in the background. It is open floor for questions. So if you are here right now, you can have your question answered. What's up, Aaron? Good to see you here. What are you working on? What are you working on? We get trace on the description. Tree model for classification. Get an error when I run. Visualize tree. Whoa, what's going on right there? Trace, do you want to send me that code? What's up, Ziad? Good to see you here. Visualize for tree. So visualize relationship tree. Send me the code. Kayla, great to see you here. Oh. Ready to go, ready to learn. If Trace should send me that code, I'll take a look at it right here. Trace has got a message to me. Trace says, also, I think other point of reference. How you should be very impressed with. Oh, awesome. Oh, wait, what's that right here? Oh, that's awesome. Yeah. I'll have her. Yeah. Since it deals with using. Awesome. So, do we use. That's so cool right there, Trace. Pretty sure that's you, Trace. In the I'm looking over here at. That's awesome. Congratulations. If you want to share that news in the chat, you're welcome to. I'll let you share it. But I'll let you share that right there. It's open floor for questions right now. I got quite a few Discord messages I got to get to. So taking a look at those. Take a look. Let's see right here. Let's see. Let's do this. Questions. I have decomp, mean, random walk, Arima, neural nets, models for app. Yeah, Ben, that sounds awesome. Great job, Ben, right there. Awesome. Wait, here we go. Trace sent it in. Awesome. Okay, so I can't show this. Let's get Trace's model right here. Which line of code is it on, Trace? Which line of code is it on? I'll send your RMD. Awesome. Ben, that sounds absolutely amazing. Ben, it looks like you are on the road to 100 right there with your models. Trace said the problem was on visualize. Visualize. There's the visualize tree. Let's see if everything created right here. I'm going to run all the chunks above. Line 103. Everything's running. Might take a moment right here. Looks like things are running. Looking good. Let me look at your train your holdout. Always look at your train your holdout to make sure they created properly. Did create properly. Fit control looks good. I always like, ooh. Oh, it's because the lines. And okay, we got the warning. That's fine. Our part's working. Watch it work for me over here. It's 103, right? What's a different line for me now? Oh, and then you made your R part right here, the visualize the tree. Oh, it's working. Oh, visualize relationship. Okay, wait. So here is error in LOS. It's the LOS method. Predictors must all be numeric. Are you getting this right here, Trace? That the predictors must all be numeric to get the LOS right there, to fit the LOS relationships. So this is also using LOS right here to fit them to the model. If you're getting an error on 103, let me see. Or you might be getting an error on a different line. Yeah. That's the error you get. So the LOS method right here is the smoothing method that we're talking about. Trace, I'm thinking if you're in 475, the LOS smoothing method, it's mad about this. And so for the diabetes data set, this is the categorical data. You would be able to get it if, and is it mad? Predictors must all be numeric. Well, wait a minute, is there a quantitative predictor on here? It's not a quantitative predictor. What's it doing? Interest, diabetes. Let me look at this right here real quick. It's a good question, Trace. On train, marginal. Why is it getting mad? Figure too large. That's fine. And let's see if you have questions so close to that 2.75 bonus. Let's give some more points out here to Ben. If you have questions, we're just working with some people's projects right now, trying to get them fixed up. 100 points, starting out those office hours strong. Mubot, thank you so much.
I am Mubot.
Talking over me, Mubot. I'll show you something really cool here also, Trace. Let me show you some nice output. It's in the Rattle package. Here, I'm going to show you something on the screen, so this is not too much. So this really doesn't give away anything if I show this, but I want to show you a package right here. It's the Rattle package, which I do not have. So this is how to make some nice looking trees right here with the Rattle package. So Rattle package. Go to Rattle. And in the Rattle package, I have no idea why it's called Rattle. If we take our tree right here, visualize relationship tree, and we go to fancy, that's it. Fancy R-part plot. And we go to our tree. Yes. It can look better. It's a little bit small right there. Oof, that output, though. Let's try and make it bigger. It might help it. Let's read too big. Hey, Ahood, good to see you here. I have one question. How do we determine if the plot has a trend or not? Looking at the linear relationship to see if it has a trend. You know, it drives me nuts how these, yeah, the outputs sometimes are just not so good for these. Just the visualizations can be sure, let's just do this. Okay, now we're getting something. You know what we might be able to do? Might look at ggplot. But this looks a little bit better right here. It's telling you the decisions made across each section right here, the yes and the no. This is something I found a while ago. The Rattle package has a better way of plotting trees. You can also see via the coloring where your yes and your no groups are to see here's your yes group for diabetes and your no group all the way over here. And the darker the shading towards a certain direction is going to be more likely yes. So really it comes down to glucose. These are people, is your glucose less than 158? No. Well, then you're probably going to have diabetes. Is your glucose less? Yes. Is your glucose less than this? Yes. Then you're super not likely. Very, very low glucose right here. A little bit better of a visualization, but we're going to look for one last thing right here online. Let's see here. ggplot trees. Our part. Plot tree in ggplot. Ooh, someone's asked for it right here. The auto rplot function in package can get you part of the way there. Ooh, that does not look good. And literally someone's suggesting Rattle. Yeah, so this is a 2020 question right here. Someone asked of how to get a good ggplot of this. Here's the original visualization with the rplot. So they're getting this sort of visualization we see in our notes. That's the notes visualization. Someone then suggests this package right here, serve miscellaneous. I do not know that package. I mean, don't love it. Then, which is weird, this one's got more upvotes. That dude must got friends because I'm still partial to Rattle. I mean, for a smaller tree, it's going to look better. About numeric input tab not working for one of my plots. Yeah, look at that next. You got it. And then wait, Ahood's question first. How do we determine if plot has a trend or not? Basically looking if the plot goes up or down, if it's not going to be stationary, Ahood. Does that make sense, Ahood? If the plot is not stationary, then it's going to have a trend going in one direction. So if we see like this increase or decrease in it, we usually think of a linear. Sometimes it can have a non-linear trend. So what kind of relationship are we dealing with over time? Like a constant increase, constant decrease, or some sort of polynomial trend, which would be much harder to get out of it. Man, I don't like the answer to those questions. I'll look into your code a little bit further. Here's the good news, Trace. You will not be graded on the LOS method for showing how your predictor X's work across a window, which is really interesting to use. And we do have additional notes on that in the extended notes for those slides. But the LOS method is really mad because there's categorical. It's not talking about the categorical Y. You could not use the LOS. For those who are in 475, could I just, destroy that line of code. The LOS method does a window and does a weighted average across. We talk about this in 475, how it looks at a regression across a window. And that window then uses a weighted average towards the center of the window, creating a line that kind of smooths it out. And the bigger you create the window, the more smoothing you do across it. So for autoaggressive models, I understand the difference between ACF and PACF, but still good. Oh, we can do that next. I heard you got it. We're going to do Ben's question, and I'm going to see if I can find... I really want to find a good ggplot for this. They're using Rattle, aren't they? I'll show it. Show it in the background here. Everyone uses Rattle, it looks like. So they're going through here, showing everything. Our part plot. Is that what ours is? What? It's not much better. It's like Rattle. I mean, cool. Can we throw that in it, Plotly? Answer is nope. I don't like it. Yeah, the quest for the perfect visualization never ends. Yeah, I don't see. It gets hard to visualize trees as they get really big. Yeah, they're even showing a crazy tree back here. Like, as your trees get really big, it turns into a bunch of nonsense. And you can see here, we are getting, as we grow the tree bigger and bigger, a lower and lower complexity parameter. And there's the naive model right here. Mixed val relative error, so we are increasing our error right there. Here's the tree growing bigger and bigger and bigger. Yeah, they're just trying to fit their tree, trying to tune their tree. And here's their variable importance right here. So, ooh, that's cool. That's cool. Can you... That's a cool... That's plot 3, is it? Cool. Let's take a look at Ben's. Also, when you make the tree, why is it on the train data? Should that be trained to holdout? Oh, no. Always make your trees on your train, because then we're going to test it on the holdout. So you will get via the trees, it will do the out of bag where it does the validation for you. But you always want to make your forest and your trees on your train, and then you see if things work on the holdout. So if you want to see if your models work on the holdout. Let's look at Ben's question next. They're talking about some output. So always make your models, and working app right here. Always make your models on the train. So important. Make models on train. Like yell it. Make models on train. Because that's where we learn and create our models, and then we see if they work on the holdout, because that's our final test of the model. Like, does the model actually work? And the answer is either yes or no. We have a good similar validation. So Ben said, a numeric input tab not working for one of my plots. The tree. Yeah, well, you could. As to like understand the relationship, and the whole point of the holdout is just to test if it works. And then you could probably, I guess you could visualize it on the holdout to see how it works on the holdout and how it classifies things. But the training is like how we learned our data and what we believe the truth is. And then if we fit a tree to the holdout, then we'll just be overfitting a model to it, because we'll be putting something on it and making sure it works. Which is just weird to people to be like, well, don't you want it to work? And it's like, well, the point of the holdout is to test to see if it works, not to make something work on it, to actually know it works by having something we don't know works on it. And then if it works, it actually works. Which thing has been, let me see here. Sorry there, everybody. Oi. Oh yeah, let's see right here. The train and holdout tab has a holdout input, but is not working. The holdout, I have a holdout numeric input in time series tab, which works, but I don't want the user to have to switch back and forth to the change holdout. Okay. So the train and holdout tab has a holdout. Okay, let me look at the tabs. I'm looking at this here. Everything's loading. Good. Okay, the train and holdout tab. Let me load in some data. Okay, The train in the holdout tab. Okay. Has an input, but it's not working. I have a holdout tab. I'll go to the holdout tab. Wait. I have a holdout numeric input in the time series tab, which works in the time series tab. Oh, and this one works. You are very correct. It does work. But I don't want users to switch. So, okay. Oh, wait, is this? Oh, it is working, but it's doing a different thing. Or is it not? Okay, I think... Do you have your permission, Ben, to show this right here? Oh, thank you. Ben even said I can show it. Thank you so much. And what we think the holdout will break. Exactly, like, kind of to make it... Yeah, exactly. Exactly, Trace. And so, yeah, I've got it working in the background right now, and let's take a look. So, like you're saying, this one doesn't do anything. It doesn't do anything. So, I'm interested to see why it's being colored this way. I think it's actually... time series plot has it. I think it's actually working because if you go back to here, you can see it is working. You are creating it. You do have everything connected. This box is not... Do you want someone to just input... do you want someone to input a value here? Like, where do you want... Because right now your time series plot is taking the value. Like, if I go to 50 values right here in your train holdout, you will see this is what's being held out right here. So, do you want someone just... Hey, what's up, Leah? Good to see you. Oh, so Kayla's pointing out you can't use the same widget on multiple pages because it's going to take the input right there. So we need to give a new input name to this widget right here. Number of periods hold out. Let's go look at that. And there it is right here. So did you call this? Here it is called right here. This is, yeah, because you're creating two inputs. So this needs to be holdout 1. And this needs to be holdout 2. So it's same input ID. Boom, right there. Kayla, 100 points, Kayla. Kayla's immediately diagnosing this issue and saying we have the same input ID right here, and it's getting confused. So that looks to be, yeah, Kayla, can you just, I seriously, yeah, Kayla's super quick on these things. And this is the way you understand these issues is you hit them. And you say, oops. One time I tried to use the same tab on 2 pages and it said no. So now what we want to do is we want to search for that input, $ holdout. And this right here is your reactive train. How many input $ holds do we have? 1, 2, 3. We have 3. There's the TS data. And there's the TS data 2. This is where you're getting your train. I don't know which one's used where. Let's just take a guess. 1. Did I call it 1 and 2? Holdout 1, holdout 2. Okay, cool. And input $ holdout. And let's call this 1. Sure, why not? I mean, we've... Oh, 2? That sounds like second time you're doing it. Okay, so we got a chance at being right here. We've recoded all those. Chance we're right, chance we're wrong. Blank the screen right here. Open question, or I think we have one more question after this. So get those questions up and going. We got our data loaded up. And let's go here to time series of it. And let's go here to time series plot. Go right here to 20, and boom, we're deleting off some data. Go over here, and whoa. And it looks like we're already deleting it off in here. Well, that's interesting. It is reacting to this. Oh, whoa. Be careful. I've done some crazy stuff to you right here. I would not do it this way. What does the CP in the vanilla partition handle? The complexity parameter, which is how much we are splitting our tree. So here we'll take, I think it was Trace, you had another question too, right? So we got Ben's issue all fixed up right here. Ben, great job. You get stuck, you ask questions, you get unstuck here on Stat 201. Let's do this. Lunch. It's done. Let's see right here. I think Trace might have had a question first. Trace has a question that comes before Trace's question. You're welcome, Ben. Ben, thank you so much. Just, you get stuck, and then we fix it. Was there a question I missed? No. Ahood had one. Let me do a Hoots question, then we'll go to Traces next. For autoregressive model slides, I understand the difference between ACF and PACF, but still cannot figure out where's the cut. Okay, let's go look at some models right here. Okay, time to look at some models. So this is for autoregressive models. So looking at some autoregressive models right here, let's maybe see if we need one. We're going to load up some library. And now that we have FPP3 loaded up, and it loads up everything else, all those Fable tools and all that good stuff, we're going to load up, let's load up FPP2. That one uses Tisbles. Okay. Data. And we got all this stuff right here. So many options. FPP2. Calls. 5-minute call volume handled on weekdays. Australian tourists. And this is data quarterly. And do we have autoregressive right there? Probably some autoregressive, maybe some seasonality here. Let's take a look at some Australian tourists. Everything we do is Australia. And what's the first thing you think we should do with some data before we... let's investigate a little bit of data, then we'll do Trace's question next. What do you think we should do with data first? I've got 2 ideas I would like to do, and they both center around this. What would you like to do with your data first? Really good first thing to do with data, some of the first things we talked about, is to do what with your data? I feel like this should be a test question instantaneously. Very first thing you should do with your data when you get data is probably do what? I've got data. I got this Australian tourist data. I don't know if I need to use an autoregressive model right now, but maybe I do. What should I do with my data? Check it. How do I check it? So you might say validate it. Let's say we validate it. Validate it, good. Validate it, clean it. Validate, looks valid, looks cleaned. So validate, clean. Set class, all that good stuff. Validate it, clean it, store it. Good stuff right there. We got it validated. We got it cleaned. Okay, we're good. It's valid. It's cleaned. It's in the right class. It's the right class of object. It's a time series object. It's a time series object. What do we do now? What would you like to do with your data now? Choose your own adventure. What shall you do with your data now? Your call. What would you do with this data now? Since this is one of the last classes, I want people to be thinking what they would do. I think there's a very important thing to do next. Yes, exactly, Thompson. Some 50 points right there. Start plotting it. Let's take a look at this and see what's going on with it. All we're doing is just trying to diagnose this data and being like, what's going on with it? Great job right there, Hood also. We're going to plot it. We're going to take a look at this. You could TS plot. TS plot's okay. That's in the stats package. It could probably handle this object. Should be able to. It's a time series object, right? I mean, that's cool. You know what's more cool? Autoplot. You know what's more cool than autoplot? Autoplot with a little ggplotly on it. All we're doing is nesting code right here by saying take this autoplot and now make it into a ggplotly object. And ooh, in seconds right here, what do we got? Pretty nice looking graphic, and you could add titles to this, and that's why I like the plotly stuff, is because we can just go here and go to ggtitle, 1T in title, and just say Australian tourists. And now we should get everything we want. There we go. That's how you spell Australian. Australian tourist right here, and we can hover over and see all the great values. Does this look like a multiplicative or additive series? Does this look like a multiplicative or additive series? Is this mainly multiplicative or additive? Put M in the chat or A in the chat. That has nothing to do with moving average and ARIMA. But does that look multiplicative or additive? Mostly. Good review of concepts right here. Is that probably a multiplicative or additive series? Which will go to the ways we're doing decomp. If we decomped this, we could turn it into a multiplicative or additive series by decomposing the components of it. What do you think? Mostly multiplicative or additive? Mostly. You might say, well, you know, down here a little... Nah, I think it's mostly this. What do people think in the chat? What would it look like if it's going to be additive? And what would it look like if it's going to be multiplicative? So if it's multiplicative, we usually see a change in amplitude. If it's additive, we usually see a constant amplitude, like it's adding on to the previous one and kind of following a trend upwards, which we can take out this trend pretty quickly. Let's go here and remove out that trend. Let's go to trend. Let's go to difference of the Australian Taurus. And now we're getting the values of the differences. We lose one value because we can't difference it from the first value. But if we auto plot these differences right here, it's going to look a lot more like this. And I'd say it's additive. And it's a little multiplicative. Maybe it looks a little, I don't know. You try them both, see what you get. We are seeing very large seasonality right here, which the auto ARIMA is going to pick up on. Like this is your seasonality component right here because this has a seasonality frequency of 4. You can check your frequency of the data by going over here and doing frequency of your Australian Taurus. And the frequency of our Australian Taurus is going to come back with 4 because we're dealing with quarterly data. You can see it right here, the data. But let's see right here if we have in the remaining, let's just say we have a different series right here. Let's call this diff aus and the difference Australia. If we go and look at this, we can go here to TS. Forgetting the name of it. TS. Oh, no. GGT. TS display. There we go. You can get it via check residuals also. I'll explain why I like this better. We should be able to do this right here. And taking a look. Ooh, got some stuff. Oh, this is beautiful. Beautiful. Where's the decay at? Before I submit everything that I need to submit in RMD, correct. You need to submit your code, your RMD, and you need to submit explanations. Great job, Connor, right there. Does the CP decrease impurity? Yes, of the original data. It's going to make it very, very, very well classified, but maybe overfit. So it's going to help with impurity, but it could, so lowering complexity parameter also decreases impurity. Increasing complexity parameter would increase impurity because you'll go more towards the naive model. Because it'll be less complex. It's weird. Complexity is reverse of the way you would think it is, because if I say lower the complexity parameter, you're actually allowing it to grow bigger. So that's where I think the confusion is on the complexity parameter. Because I say use a very small complexity parameter, you're saying you need this much of a return to split, which is a very small return. If you have a very high complexity parameter, you're saying you need this much of a return to split, so it's much harder to split the tree. Does that make sense right there, Trace? Like, people think of it in reverse, but it's how much of a return do you need to split the tree? And you're saying we need this much of a reduction. So if you allow for a very small one, you're saying you only need this much of a reduction, very, very tiny reduction to split the tree. So you'll split the tree a whole bunch. But if you set the complexity parameter very high, you say you need a huge return, so you won't split the tree very much. The higher the complexity parameter, the harder it is to split the tree. And so this pattern right here is really indicative of, see, I'm wondering, see, this right here is where the decay is happening. This might be some sort of crazy pattern, but I'm seeing decay. I'm seeing decay on the seasonality. Seeing decay on the seasonality in the ACF. Is everyone else seeing that? Like, here's your seasonal lag right here, and this might, it's just weird. You might, some mishmash of things are probably parts of this, but the seasonality is having a big decay because you're seeing every fourth right here. Yep. That works excellent. Great job, Connor, right there. Totally 100% can do that. Yep. And then you're seeing just a drop right here. So I think the seasonality component, so you got to remember MA is a moving average. Let's go ahead and we can do our differencing via the ARIMA. So our differencing that we have right here, maybe we need differencing on the seasonality. Let's look at that. Let me take the Australian. Where's it at? Which one is it? Had a second ago. Aus Taurus. And let's do the order. Let me take the code up here, because I can set it off separately. So what we should get is if we go here to order, and the order is equal to a concatenated vector. There's that. And we should get seasonal. And please note I'm using capital A ARIMA. This is the one in the forecast package. It has a capital. I like the syntax of it a little bit better, like the way in which you put things. There's the ARIMA model right here. Let's save it out here as the fit. And now let's go to the check residuals on it. And nope. Go away, check regression. Check residuals. And let's go to the fit. And let's go to the residuals of it. And we are seeing, yeah. There we go right there. So we are seeing the same pattern right here. And I'd say so that we should probably throw in, we see decay on the seasonality. So let's just toss in right here and see what happens. Oop. What happened? What did it get mad about? Inappropriate degrees of freedom for the model. What's it mad? Wait. Check. Could not find appropriate degrees of freedom for the model. Oh, it changed. It did change. It's not loving that. Let me try differencing the seasons real quick. Okay. And let me look at the full plot of this now. So GG time series plot. Okay. Where do you see the sudden drop right here in seasonality? And actually, this gets into it right here, Ahood. So where do you see the seasonality just cut off? Where do you see the seasonality cut off? Where do you see the seasonality cut off? Like the seasonality, right? One of these has decaying seasonality, I would say. I think so. It's hard to tell. But I think one of these has a cutoff in seasonality. One of these has a more of a decay in seasonality. Which of these looks to more cutoff on the seasonality? Which of these looks to more decay on the seasonality? And the residuals right here would not need a transformation. We're looking good on the transformation. And there is negative first order autocorrelation. I might go for that first. Right here on the PACF on the seasonality, does this make sense how we see a peak right here and then it's gone? There's no more significant lag on seasonality right here. So this is going to cut and then we don't see any significant across here. But if you look right here, it's hard to tell a little bit. We're seeing another spike-ish. I think this is more of where your cutoff is. So I might go in this one. It's hard to tell because there's a mishmash of things going on right here. We might go for... It's going to be some combination. We can audition a few models right here and see how they work. But overall... Let's go for a 1 over here. Let's go for autoregressive 1 on this and autoregressive 1 on the seasonality. Let's see what we get. So remember AP, because we're saying it cuts off on these. We'll see what we get. See if it's any good. And how are we looking? Oh my gosh, look at that. I love it. I love it. Love it. Love it. There we go. Wow. What if we had gone the other which way? Uh-oh. What do you think of this right here? I mean, this is great. This is amazing. We've done it. We've done it. Ah, let's see what the Autorema does after this. I think this is a different one than we did yesterday. I don't think we did Australian. No, we did beer yesterday. We didn't do Australian tourists. We did the Australian beer production. All data, all Australia. Oh, because the guy's from Australia. The guy who made this data set stuff is from Australia, so that's why everything is Australian. Thank you so much, gentleman who made all this data. Heinemann or something like that. Nice job. So if you look right here, we've really got it down to probably a white noise process. If we look at our check residuals, are we not getting, the degrees of freedom? The reason you're getting this problem with the degrees of freedom is it can't run the test. Not the end of the world that it can't run the test. So we can't get a mathematical computation to see if we have problems with our residuals. That's a little weird that the model's fitting so well here at the start, but we'll take it. If we reverse what we had done right here, we'll see how our other model had looked if we reversed it. If we had went with the MA version of this, what would we have? And the answer is pretty good too. Yeah, maybe a little bit better. Well, then the answer becomes fit 1 or fit 2. Now, we didn't do one very important thing with doing this, and actually we might be able to get the answer out of this. Fit 1 or fit 2, we should be able to go here to the accuracy of the model. And there's the accuracy of our first model. That was the first one I thought it might be. And here's our accuracy of our second model. There's our accuracy of our second model. Oh, look at the better RMSE down here. Better MAE up here. Well, everyone knows I'm a fan of RMSE right here. So maybe let's go crazy right here. and just make a mess. And then we'll look at what the auto AutoArima does. This is just going absolutely crazy. And we might be overfitting. And there's, oh, well, we got to look at the residuals on that now. So there we go. There we go. Fit 3. Is it mad about that? GGTS display. Oh, fitted the residuals. Sorry. And fit 3. Well, even better. Well, so maybe the answer was it was a little bit of autoregressive moving average model. And so this is giving us the best model right here. I would fear it's overfit. I would fear maybe some overfitting right here. We could plot the fit of the model right here. Should be able to get the auto plot of the fit of the model. And we want the forecast of it. And you know, that looks like a pretty good model. We could look at our different models, and this might be a good one to audition Fourier series, some good old sine cosine waves through this, because this does have a pretty good stable pattern. Exponential smoothing models could be looked at for this, because we could take the difference in the levels, difference in the seasonality. We didn't talk much about exponential smoothing today. The accuracy that is in the output example, diabetes, is the percent of time that the model predicts yes, that someone has diabetes. Accurately predicts yes and no. So Trace accurately predicts yes and no. So we want to accurately predict someone has it or does not have it. But as I went through this here, does it make sense? And we're really just trying to get it down to this plot right here, where we don't have any remaining variation. We have what looks to be, I am a little worried about this. The model does really well at the start. So looking through, and we could look at the fitted values of this compared to the actual model. We should be able to do auto layer. Let me try that. Auto plot and auto layer. So we should be able to auto layer, which is such an amazing feature. And we should be able to go to the fit 3 and go to the fitted model. Is it going to auto layer? Yes, I love it. Here we go. So there is our model fitted over it. We can kind of see where the model, this is where we don't have, oh, there's where it's fitting perfectly. It's literally on top of the model itself, and then it starts to deviate. This is where we were seeing in the output previously, the lack of residuals. So here, let's put that plot on here at the same time. But we were seeing previously, check residuals of fit 3. There we go. We're seeing down here at the very bottom of the model that there is no issues with the fit, and the red and the black line are completely on top of each other. Is this all making sense here, Hood, to see how these plots connect? That I thought for a moment we didn't have the black model down here, but the model is doing a perfect fit on this data right here. And hence, when we calculate the residual, which is one more forward, the residual right here is having no error. Actually, I think we might have a tiny bit of error. Might have to zoom in. Yes. You can see the black line just barely there. And that's noticeable because we have right here a tiny bit of error. So there's a tiny bit of error, then the model goes perfect, and then we start to see little jumps, and we see a jump below. So here's where we start to see the deviations. And we have a big jump right here at about 2003 or so. And that's the big jump. Is that the big jump? Here's a big jump over here. So it should be a jump up and jump down. That's the early jump up and jump down. Jump up because the model is, this is the fitted. That's the jump down because we are below the prediction of the model. That's a negative residual because the actual is lower than the predicted. And then we're seeing a little bit of an up right there. So important to kind of know what's going on, that this is the, when the model would be up here and the prediction is going to be below it. So yeah, then we should see a high pattern right here where we're above the fitted model. And that high pattern right here is where we're above the fitted model. This region in here where our model itself is above the fitted. But overall, this is a really great model. Is it overfit? I don't know. Let's see how the AutoArima did and what the AutoArima selected for us. Did we beat AutoArima today? That's always our goal. Beat AutoArima. And the AutoArima on the Os Taurus is going to output a model that is a 10110. So it took the auto-regressive on both the order and the season. It differenced the season, and that's all it did. Maybe I overfit. Fit number 4 right here. And so we look at fit 4. And what's really great about writing good code is we can just take and plot this down here with fit 4 and change it up. So let's see how fit 4 looks. Here's the 4th fit, very similar. Did we finally beat AutoArima? We tied it last time. Let's see if we beat it. And now we want to go to our accuracy of this model. Here's our accuracy of our previous model. It's going to be a close call. I don't know. Let's see if I beat it. The answer for did Brian beat AutoArima? Here's Brian's model. Oh, clear the screen. That'll be a good way to do it. Here's my model. Here's AutoArima. Oh my gosh, come on. AutoArima. Which model wins? Oh man, so close. Which model wins? And I'm happy with it. I'm fine with it. I guess one of the issues might be that, well, you want that close to 0. That's the mean error. So there's a little bit of an issue there, if I'm to say, about my model. So we came close, but which model wins and why? Important to know by looking at this output, usually we judge our models, which is just one way to judge the models. Just one way to judge it. My final model that I said, here's my model I'm going to use, trying to beat the AutoArima. Now, the real good way to look at it is to see if you beat it via holdout or cross-validation. So we'd probably want to look through some cross-validation to see if we're really beating this right here. If my model had an accuracy, we'll do that one next. You got it, Trace. But is this making sense right here, what we did, how we went through this? Fit 4 is better. Are we looking at the RMSE here? Correct. And they just barely beat me. In truth, the RMSE probably has enough uncertainty. We look at that in 474. I wish we got RMSE standard deviation, but we're not doing like a k-fold cross process right here, so we can't get an uncertainty because we don't have multiple repeats of it. But this is just one estimate of what the uncertainty is based on one sample. I'm guessing my model probably is close to it. That might be a little bit of an issue because we don't want the mean error to not be 0. That means my residuals might have some sort of, it's small, but theirs is better on that regard. So they win pretty well here because we don't want a mean error that's off 0. I call it a tie right there. I'm just going to call it a tie. My MAPE is lower. Beat them on one thing. Sure, let's go by MAPE today. Let's just change our standard. I'll just pick the standard I win on and then say I win. So don't do that. Don't have shifting standards. RMSE all the way. That's what we do in this class, RMSE. I lost, but came close to that. If my model had an accuracy of 80% and 76.86% on the holdout and the AUC on the training is 79.52%, then the model would not be overfit. Correct. So accuracy, you can get your AUC on the holdout. Do you have your AUC on the holdout, Trace? Trace, do you have your AUC on the holdout? So to compute your overfitting, which it doesn't sound too bad. Tiny bit overfit. There's your overfitting right there. You're welcome, Ahood. Great questions. And we didn't do exponential models today. So we need to make sure we cover those. We'll cover those tomorrow. Tomorrow's gonna be all review. Oh, the AUC is wait. You switch between the AUC. Okay, good. Or wait, is that the accuracy or the AUC? Just take how your model does, and we want to look at, wait, I reversed the numbers. We want to look at how your model does on the holdout. So the holdout is this, and you don't want your model to work too much worse on the holdout. So that's kind of your overfitting right there. If I have the two numbers, if that's it right there, that's kind of, we want to look at, let me retract that one message. Because you're saying your model would now work worse on the holdout. Does that make sense if I compare those numbers? So if we have a model that works really great, like if I classify things 99% of the time correct, and then we classify on the holdout 92% of the time correct, well, that's like a 7% drop. We can calculate exactly. Like on the holdout, I do 92% correct classification, and on the train, I do 99%, or the validation I expect to do. I mean, that is a drop, but my model's still working pretty well on new data. It's a little bit overfit because overfitting is not really a question of yes or no. It's like, when is something hot? Does that make sense, Trace? Like, when is something overfit is a matter of degree. There's no moment at which your model's like, that's overfit. It's like it's like if something's overfit, you know it, because it just gets really bad with new data. And what's really bad? Well, imagine I tell you my model can predict things accurate all the time, and then you use it and you're like, it's wrong half the time, and you're like, oh, that's really overfit. Would that be, yeah, your model might have like a 3% drop, and then do it as like a ratio, because your predictive power, here, let me show it this way, let me explain on the screen. If your model is expected to work with an accuracy of 80%, so this is what we expect, and then you observe your model working with an accuracy of 76%, you're observing your model work at like what percent of it, the accuracy you expected. So you're observing your model, just think about this question this way, you're observing, and these are all could be values of AUC, could be values of the classification. You're observing your model work at what percent of the expected value. So you observe your model working with an accuracy of 76%. You expect it to work with an accuracy of 80%. So now we would have what right here, which is a great way of thinking about this. How good is your model working? Not really 95% of the time. It's working at 95% of what you perceived it would work at. Does that make sense? So it's not 95% of the time accurate. It's working at 95% of what you thought it would do. Does that make sense? So that's not that bad. If I make all these claims and I'm about 95% of my claims are true, then you're like 95% of what I said would happen happens. You're like, hey, that's pretty good. I mean, when you start to get below 90, you're like, not so good. And all we're doing right here is just taking 76 dividing by 80, and we're seeing that its accuracy is about 95% of what we thought it would be. We thought it would be an 80% accuracy, and this is what you're getting on your train right here, where your validation, which is a subset of your train. And this is what you're getting on your holdout, which is how it's actually working. So if you take the holdout and you take the train, or the validation, which is inside the train, and you talk about, you know, it's working at 95% of what you perceived it would work at. So I'm supposed to divide the holdout AUC by the So you divide the holdout. But now if we talk about RMSE, your RMSE on the validation might be something like, let's say that. That's your RMSE. You're predicting sales. And then your typical miss on the holdout, which was what RMSE is something like this right here. So explain this value. So explain what this then means, what this RMSE means to your boss. Take a moment. I will throw 500 points if anyone can explain this very well. 100 points for an attempt. Blow the points out of the water right here on one of our last days. Adam, good to see you here. Your boss is having you predict. Awesome. Adam, you can help out with this one if you want. Crazy points here on these wacky Wednesdays. So I get 96% of my model. Well, not 96%. It's like the amount it's working as to what we expected it to. Because it's a ratio of this is what we expected it to work at. This is what we observe it working at. So it's working at like this amount of proficiency. And that's from like AUC and accuracy. But this one's a little bit different. So your boss wants you to predict sales. Here are, I hate that it does that. Here are your RMSEs. Explain them to your boss. Trace, super close. Trace, you're super close. Compared to what we believe to occur, the validation we missed. What do you mean we missed by 1.16? I mean, you're getting there. Let's keep reshaping it. Let's keep reshaping it. Compared to what we believe to occur on the validation, because that's our estimate. That's where our estimates come from. We missed by 1.16 on the holdout. What do you mean 1.16? What do you mean 1.16? We missed by 1.16 on the holdout? We missed by 1.16? I don't get it. And look at the numbers and think about how the 1.16 comes into play right now. Heron's in Pog tier. Love it. So I'll explain here in a moment. I want to give out the points, so I don't want to explain it. We're at 100 points. Let's get to 200 points, at least. So just be thinking through. Your boss is having you predict sales, so you expect to miss sales by $537. You expect to miss the sale predictions. Like when your model makes predictions, we saw some predictions a moment ago. I deleted them. Can we get those auto plots back up? Can we get some auto plots in here? You expect to miss sales by a certain amount. So you're going to miss by a certain amount. And then on the holdout, which is the new data, the data you don't have answers for yet, that you're going to test it against, on the holdout data, you miss by this amount. So just think, this is what you expected to miss by. This is what you actually miss by on new data. And this is the ratio of the two numbers. On average, our model typically misses by, well, that's what we see right here. So Thompson on the right track, 200 points. Let's bump it up to 200 right now. On average, from the data our model was trained from, you know what we might be able to do? Watch this. I don't know if I can do an H line on this. Can I do, these are auto plots. So let's GG. No, I don't know how to do an H line, or at least with that plot. You can add geom H lines and stuff and put a line in. So on the data, this is not the actual numbers to this day, we're just pretending. On the data the model was trained from and we got a validation, we estimate that the model will miss by about $537 on average when predicting sales. On new data, we estimate that our model, or on new data, we observe that our model misses by on average 623 when predicting sales. So what does this number here mean? What does this number here mean? What does taking, compared to what we believe would occur in sales, closer. Trace, 300 points. You're a lot closer, Trace. Compared to what we believed would occur for our misses on sales, that is a great way of doing it because we're comparing to what we believe will happen and what we observe happening. Great start with that. And then the misses we had on new data were what? Be very careful. Just think about how the numbers work when you go to this right here. And so you're almost there. Trace, you're at 300 points now. That's almost there. We're almost there. Just keep thinking through as I can say the answers, but if I say the answers, that doesn't help people learn. So I want you to think of the answers. And the more you think about this, the more you solve it through in your head, it helps. And then I'll say the answer a few times to make sure we kind of learn it. But you have to be like, what does it mean? What are we doing mathematically? We're comparing what we observe on new data, the miss we observe on new data, to what we expected the miss would be. And we get the following number down here, which is not 1.16%, because imagine if we had this right here, and now we would get 1. So think about, since that's 1, that's saying, well, we observe exactly the misses we thought we would see on new data. Like the misses we observed on new data was 100% of the miss we expected to see. So it's the exact same amount of miss. So we see the same sort of model predictive power on new data with the example down below right now. We see the same sort of predictive power on new data that we expected to see, which is very good. Model's not overfit right here. Let me make Kale's right. Let me recalculate. The model does 1.16 times better than we expect on new data. Be careful. This one's accurate, or is RMSE. It's not accuracy. So since this is RMSE, so good practice right here. This would be worse on new data because this is RMSE. And so Kayla, your answer could be correct if you do a little reshaping. 400 points. Let me read the next few answers right here. Compared to what we believe would occur in sales for our company, we have increase in sales, not an increase. This is the error we see when predicting new sales. So this is the typical miss our model makes, or the typical error we have when predicting sales on new data. So, and we're looking at how much larger it is. Let me read who's answer right here. And Nebraska. Our holdout data doing better than our train. So remember, it's a ratio, which can be used as a percentage, and it's doing worse. Because this is RMSE, which is typical miss, so it's worse. Hey, everyone, I'm following slides right now. When I'm trying to run my own code, it's saying command is not found. I'm confused why. Make sure libraries are loaded up. Probably bin sh model. Yeah, I see what you're saying. That caught me off guard. FPP3. Make sure to install .libraries on that, Brad. That one took me about an hour of being like, why doesn't this work? Where is the model function? It's in his new book. He wrote a package for his new book. He wrote the forecast package, then he wrote a package for his book. I don't know why he has the yeah, I know, right? I don't know why he has the forecast package and then he has the package for the book. That was super confusing, and that ate up an hour of my time being really confused by that. Because I was like, if you do not mind, I'm just side noting really fast. In 474, you said 0.75 is max Gini. Is the 0.25 the most pure level? 0.75 is the max Gini with 4 groups. And thus the worst impurity you could have for each group is a quarter. Does that make sense, Tyler, right there? So yeah, it was an hour of my night just being like, what the heck is he doing? And these packages, the FPP3 package is super new. Here, I might give the answer away this one. I think we got 400 points. Well worth it. Everyone's like, join the chat. He's about to get 400 points. Given the data our model was trained from, the holdout does 1.1 times 6 worse at predicting the sales than we expected to. I'd take that right there. 500 points. And once again, thank you for working together on this. Given the data our model was trained on, i.e. the estimate we made from the validation, which is part of the training data, subsection off via k-fold cross-validation, this is the estimate we had. The model's predicted power was 1.16 times worse, or was about 16% higher. I would personally turn this to a percentage right here and say, the typical miss our model makes on the holdout is about 16% higher than what we would expect it to be. There seems to be a little bit of overfitting here. Does that make sense? It says there's no package called. Installed up packages FPP3. Installed up packages FPP3. Exactly. Yep. Nice job, Kayla, right there. Another 20 points. We'll just give 500 points, Brian. You can't give 20 now. I can do whatever I want. This is how we all help each other and we learn. Thank you so much, everybody. Don't forget the quotes. Single quotes or double quotes, it doesn't matter, but don't forget the quotes. You can call the library without quotes or with quotes. That's one of the most confusing things. You can go library, quote FPP3, and it'll load. Well, I've already got it loaded. So it's, here what did library do I not have loaded right now? 4 cats. That's not how you spell it, right? Oh, it worked. Yeah, there's no 4 cats. Okay, so it is loading that. But you don't need it all, so you can load it like this. You get the autocomplete. But if you download a package, you have to put the quotes in there because it searches the CRAN server for that string. It's looking for that string of text, which is weird in the library. You don't have to call the quotes, or you can call the quotes. But when you do library, you do not need quotes. You can use them if you want. When you do installed up packages, it searches the CRAN server unless you have another repository. I know, right, Brad? Dude, these are the things that just like, you can spend an hour being like, what's going on? And then you're like, I just need to put in quotes. I do want to point this out. One of my favorite quick tricks inside of ours, if you select something, you can put quotes around it. You can put parentheses. You can put brackets. Whatever you have selected, you can just put quotes, parentheses, or brackets around it really quickly. But that's one of my favorite quick tricks, is you just highlight something and you want to just put in quotes, especially double clicking. You double click and you just put in parentheses like that. So really, really great options. Triple click. I don't like what this does. It throws it to the other line. So I don't use that as much. Let's see if there's any last few questions. Really great review. Good stuff of concepts. Back to the main screen. Wrong button. What questions are there? We always want to be able to explain what's going on. That's the point of business analytics. People say, well, why don't we solve math equations? I say, well, math is fun. Math's the backbone of it. The more math you have, the better you're able to explain things, but then you got to practice explaining. Crazy points on these Wacky Wednesdays. We're going to be getting ready here for the Kahoot pretty soon. I'm going to probably get the quiz going, which will mainly be Kahoot questions. So let's do that. Let me get that going here soon. So I need to get all the Kahoot questions over there. I'll get the quiz going. It says model not found. Did you run FPP3? After installing it, run, so is it saying function model not found? After running it, make sure to run library FPP3, and then that'll load it up. It'll load up a bunch of stuff in the background, like Fable Tools. I think Fable Tools has library. Fable Tools has model, rather. Yeah, model is in Fable Tools. I'll show that here in the background. So if you have Fable Tools running, I'm calling the package and calling the function from the package. So Fable Tools, that's the package. If you do the ::, you'll be able to see that you have model right here. Wow, there's everything inside of here. There's model right there. Got a little left-hand side, right-hand side? What? Wow. Is.model. Well, that's going to tell you if it is a model. New model. There's so many options. Null model? What is a null model? Creates a null model definition. parse model. So many options. There's so many decompose model. My gosh. This function allows you to specify a decomposition using any additive composition. Works by decomp. Absolutely insane. Selena! Awesome. Good to see you. Tell me why my YouTube still tells me when you go live. That's awesome, Selena. So glad to see you here. Let's throw out 100 points. Selena swinging by. It's still saying it. Probably we might need to take a look at this. See what's going on right there. I sent an update on Discord, got the flip box to update on toggle, added exponential and holds, and oh my gosh, wondering what range I should add for the user to control alpha, beta, and gamma. So that's the amount of information you're taking backwards. No man bun. Oh, I have that video. I have the video. I never posted the man bun video, but I do have this video. Go stop the music. Probably you've seen this video. Hey everyone, welcome to Stat to One. How are you doing this morning right here? How's everyone doing? Everyone doing all right? I think I got something in my hair. Just one second, real quick here, everyone. Oh, it doesn't. Oh, it doesn't work that I have a new background. Doesn't work that I have a new background. That's only like 3 months ago now, or 2 months ago. Craziness. And my hair's all short. What'd I do? But I do have a man bun video. We made a man bun video where I'm like, it's man bun video, it's man bun time, man bun on Stat 201, man bun all day long. Yeah, it got crazy long, Trace. It was all the way to my shoulders. It was like, and then I'd just be like, rah, rah. And now I'm used to the short hair again. It's bad. I'll let it grow out again probably, but had to pop in. Man bun Brian, bring back the beard. Now the beard happened last year. The beard was last year. Alpha, beta, gamma ranges. You know what? Let's look at the good values on that. Let's look at some ETS. So we got here the ETS. Which function are you using? You know what's interesting, Kayla? ETS is in the Fable package. Well, you probably have to use a Tizbolt for that. So let's go look at the ETS. Let's go look at the ETS right here. So Kayla's wondering about the exponential smoothing parameters right here. Let's go take a look here. And we want to look at some alpha, beta, and gamma right here. They're set to null to begin with. And let's go down here. I'm just thinking for the amount. Oh, you're using the, that's a different function right there. Which one package is that in? That's in the forecast. Is it, let me see. Where's ETS at? It's in forecast also. Yeah. Exponential smoothing. Here we go. So does this have a gamma? Alpha, beta, and does it have a gamma? It does have a gamma. Oh, with the Holtz Winter. So does it, gamma is in the Holtz. There we go. So they break it apart right here with these to give you either the seasonality right here. So if you go down to the winters, you're going to get the seasonality. So you're going to get the gamma for the seasonality parameter. It's just the amount of information you're taking backwards. You might go for very low parameters, especially with your gamma. Because with the values of phi, I always forget because they change the name of them all the time. I would probably, here's what I would do, Kayla. I'd set a value between, if we take a value of 1, we should be taking all the value from the most recent information. If we take a value closer to 0, we'll be taking a value from way further back. But you can't set a value of 0 because then it just doesn't work. It's just not possible. So you probably want to set a minimum value of like point. I would set it. Here, I'll put the sequence in the chat I would use. Tell me if this sequence works. And then you can change it around a little bit. Yeah, it's probably good. I mean, it's extreme. And then I'd probably set it somewhere towards like, and it shouldn't be a problem to do this because it's just going to update as you move across. I might do this right here. Yeah, no, awesome to see you. Been going well, busy summer, but great times. Thank you so much, Selena, right there. We're just relaxing. It's end of office hours. We're just answering questions. I would do that. I like more fine tuning of it. And if you could grab the auto values, that's probably a good idea. Or if you had a function that let you compute it, like an action box that let you compute. Kayla, don't go too crazy on these things. Don't go too crazy. And I should have included these with what we were doing. Like I should have people include these models. They're models we've done. I hope people don't forget them. Pretty easy to remember. Winters includes seasonality because it's winters, seasonality. And then the Holt is going to include the trend. And we have the level differences between just an exponential smoothing model. How can I grab the auto values? You might be able to just run. If we go right here, if we go to a Holt's winter and we take our Aus Taurus and let's go here, that should have output the model, Holt's winter. Let's go to fit of the model. That should output the fit, right? And model, here it is. So here's its estimates. There's its estimates right there. It's doing a tiny, tiny beta. So we should, if we go in order right here, here's the trend on it. It's not pulling much trend data out of it. It's pulling it's pulling very far back in the trend. It's pulling more recent seasonality. And it might be worth it looking at the residuals of this to see what we get. Let me decrease font here. Let me go to the main screen. Much easier to see. So let's go look at our... Let me do GGTS residuals on this. And the forecast has a better one. How much did we leave on the table right here? Looking good. Looking good. Not bad. Yeah, if you leave the parameters as null, it'll choose the best. And then I guess it might allow it to change. You can just let it put the parameters in, but you can allow someone to change it, which would be pretty interesting to see and watch, to have a slider on it, which is really nice to do. Do you want me to send you your code or Zoom? On Discord, right, Brad? On Discord. Is that what you're saying on Discord? I'm confused. If you send me the code via Discord, was there something you wanted me to look at, Brad? I've lost my mind. It's still saying it. Oh, yeah, it's still saying it right there. And how's this model do? Oh, my gosh, I'm losing my mind. I saved her on my fit. It doesn't do better than the Auto Arima. Damn you, Auto Arima. So good. Destroying every other model. What can you do? What can you do in Auto Arima? Just does it right there. My Discord is messed up, but yeah, it's still saying command not found. What happens when you run the following? Run the following right here, Brad. And thank you, Kayla, so much. Great questions right there. Run the following code right there, Brad, and tell me what that gets you. What does... My drink's done. Gone. Over. What does that print to the screen? It should just run Fable Tools, and that's where model is at. So Fable Tools should just run the model, or should run the library, and then the model function is inside of Fable Tools. So if Fable Tools is returning an error, then it seems like FPP3 did not install properly as a package, because the FPP3 package has in it same thing. Is working or not working? It's working or not working. Run that. Not working? Okay. That's expected. Run that. And maybe run this. Both of those should run. If they have issues, then we might need to do like a restart on R or something like that. If they're having issues, we might just need to restart. Like just restart R and see if things are working. Because it might be giving you errors down here saying something like cannot install current dependency or some sort of weird issue. But running both those right there should redo it. And then after that, run Fable Tools again. Or preferably now that FPP3 is installed, which we would hope it is. And you should see FPP3 appear here. If you don't see the forecasting principles and practices appear, and this is, once again, there's the first, there's the second, there's the third. Just keeps coming out those new books right here. When did this come out? He's got all this good stuff. I contacted him about getting the thing. I'll email him and be like, hey. When will the final be posted for 475? Tonight. The final comes out tonight. Great question right there, Ben. The final comes out tonight towards midnight. I'm going to go here in a moment and start getting the quiz posted. The quiz will be posted till tomorrow. It'll be the Kahoot questions, so you'll be able to practice. Can you go over real quick what it means for the decision tree to be yes and no, and what the percents mean? So so you're talking about like the output of a decision tree, right? Here, we'll go here on top main screen. Welcome to Stats 1. How are you doing this? Go away, haircut, Brian. Let's go look at the output of decision trees. So the percents are just the still not found. Still not found? What happens when you do the installs, Brad? Awesome job, Ben, right there. The tree that outputs, that's the percentages in the bottom groups right there. So in the very bottom groups right there, those are the percentages for each of the groups. And it stands for what percent in each of the groups are conforming to like the yes or the no group. Does that make sense right there? That it's like what percent of each of they load, and then what happens when you type Fable? Does it autocomplete? We might have to hop on So the percentages trace would be the percent that conform to the groups in the bottom. So if you see like 80% like high quality, that means in the bottom group, 80% are high quality. So we'd predict everybody's high quality. If you see something like 60% high quality, we'd predict that everyone's high quality, or the wines that are in that group are all high quality. But the percentages in the bottom of the tree are going to be the categorical responses of is it the group or is it not the group, if we're just doing a 2-level tree, which we often do. Does that make sense? And Brad, send me a real quick email, Brad, or I'll send you an email. Can correlation be causation? Let me say, yep. Awesome. I have it ready to go. Okay. So let me send this to Brad. Make sure. When looking at a decision, we see that when someone has a glucose above 155, an individual was predicted of diabetes. 84.8% of individuals in that leaf do have diabetes. I can't say it. 84.8% of the people in that leaf. So that would also be what we would predict for future observations. So for future observations, we would predict that we would see that conforming amount for future. Go to Zoom for the future. My device is running low on storage. I know that, Zoom. I never have any storage. Oh, I need to delete all those. Gosh, Zoom takes up a lot of space. Oh, we got less than a gig? Okay. Hey, Zoom. You're kind of right. Okay, let me send this. I need to delete things. My computer's running low. I think that's got it. Brad, I sent you a link. So, Brad, hop over to that link. We'll take a look. Then I'm going to get the quiz out for 475. Bonus quiz or bonus of sorts, homework, but shouldn't be that bad. Practicing those Kahoot questions. With that, everybody, we're going to head off. I'm going to get the quiz out here in a little bit. We'll be doing some Kahoots tonight for 474 and 201. So I'll see everyone here in a little bit. Bye for now, everyone. Bye. We'll be back.